Calculus, Unit 5, Day 44 notes. Our objective for this lesson is to continue discussing particle motion, extending the ideas to finding net and total distance of a moving particle over a given interval. So this topic's, again, more on particle motion, finding net and total distance. The graph below represents the velocity v of t, which is measured in meters per second of a particle moving along the x-axis. So the first question, at what value or values of t does the particle have no acceleration on the interval from 0 to 10? Justify your answer. Well, I know a of t is going to be the derivative of v of t, and therefore I want to find out when is the acceleration, or where is this function v of t undefined. And from what I learned about corners and cusps, I know this will not be defined here, 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 and here. Okay, so therefore it's undefined on at t equals, it's undefined at t equals 1, 3, 6, and 8. And it's on the interval from 0 to 10, not including the 0 and 10. Next question asks us to express the acceleration a of t as a piecewise defined function on the interval from 0 to 10. Remember, a of t is equal to the derivative of v of t. So really what I'm doing is I'm going to have a part from here to here that's all the same slope. And let's write that down. And from 0 to 1, I'm going to get a slope of 3. Now let's do the next part. And that's going to be when t is between 1 and 3. And I'm going to get a slope of negative 3. And then from 3 to 6, I have a horizontal line, therefore the slope is 0. And again, I'm looking at the graph of v of t, and remember a of t is the derivative of v of t, and I said that's when t is between 3 and 6. Between 6 and 8, once again, it's going to be 3. Again, how do I know that? It goes from negative 3, I go up 3 over 1, or up 3 over 1. So we just said that was between 6 and 8. And then the last one, probably the hardest one, from 8 to 10, I go down 3 and over 2. 8 to 10, and therefore it is negative 3 halves. So this is a piecewise defined function over the interval from 0 to 10. Okay, next question. For what values of t is the particle moving to the right, and for what values is the particle moving to the left? Justify your answer. Well, remember, the velocity has to be positive to be moving to the right and negative to be moving to the left. So therefore, I know it's going to be positive from 0 to 2, and then from 7 to 10. And let's look up at the graph. So it's positive here from 0 to 2, therefore it's moving to the right. And then again from 7 to 10, it's moving from the right. And it's negative from 2 to 7, therefore it's moving to the left. So let's write that down. Okay, and since the velocity is less than 0, the particle is going to move to the left from on the interval from 2 to 7. Okay? All right, and the last one, find the average acceleration of the particle on the interval from 1 to 8. Show your work. And all they're looking for there from 1 to 8, again, average is just slope of the secant line. There's 1, there's 8, and I'm going from point to point. Hey, it looks like it's going to be going straight across. So therefore, the average acceleration is going to be the slope of that secant line. And it looks like it's going to be horizontal and looks like it's going to be 0, but let's look at the work there. And again, average acceleration is slope of the secant line on the velocity function. And that's v of 1 minus v of 8 all over 1 minus 8. I know I'm going to get negative 7 down here, and we knew v of 1 was 3, and v of 8 is 3, and that proves that I get 0 over negative 7, which is 0. Okay, so that tells me on average my acceleration. If at v of 1 I'm going have a velocity of 3 meters per second, and at 8 I have 3 meters per second, it looks like if I end up the same, then my average acceleration is going to be 0 meters per second squared. Okay? And that'll be it for part 1 of day 44 notes, which is in Unit 5.